Good morning, students. Once again, we are here to discuss RDOE worksheet 42 from your chapter Carbon's Compound. And here are some important questions in this worksheet. And let us start with objective type questions. First, we have the difference in the molecular formula of any two consecutive number of homologous series of a organic compound. As I told you in our previous worksheet, the difference in the homologous series with two consecutive number, the formula is CH2. Okay. Then second question, how many covalent bond are present in the molecule of ethane? See the structure formula of ethane. We have molecular formula, we have C2H6. Then we'll take the two carbon, and this is how we can satisfy the valency of carbon. This hydrogen, 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 and hydrogen. See how many bonds are there. 1 2 3 4 5 6 and 7 bonds are there. Okay, this is the way we can do this question. In fact, a number of is there any, if there is any compound, you can tell the number of bonds present in that compound. Okay, number of covalent bond. Actually, the formula of second number of the series of carbon compound whose general formula is CnH2n. CnH2n. Okay, so in this case we have second number, right? This is the general formula of alkene, and we know that in alkene the compound starts from the carbon number 2, and we have to take the second member of this series. So for that second member of series, we have to take another carbon, we have to add another carbon, so C3. So we can write C3H2 into 3, that is C3H6. Then answer of this question is C3H6. Okay, so first, second, third, and fourth question, dash and dash are the allotropes of carbon. Yes, graphite and diamond. So you can write diamond and graphite, right? The essential constituent of organic compound are nothing but carbon and hydrogen. Okay, I'll write in a short form. I must. For diamond, I will write diamond and graphite, right? And carbon and hydrogen. Okay, and this and this. Okay, so next question we have, which element exhibit the property of catenation and to the maximum, and why? This answer is carbon. Carbon show the property of catenation up to maximum extent, as it form, as it is it show the property of catenation and to the maximum extent, because its electronic configuration is, because of its electronic configuration and tendency to form strong covalent bonds, right? So you can write because of the presence, because of its electronic configuration and strong covalent bonds. Next, diamond can be synthesized by high pressure and temperature. Next question, butane is a saturated, okay, compound of carbon because it will belongs to the series alkane. Okay, a compound of carbon and hydrogen having 4 number of carbon atom. Write the general formula of alkyne. The general formula for alkyne is CnH2n minus 2, and alkene, general formula of alkene is CnH2n. Okay, next question we have, draw the structure of benzene. Okay, benzene is a 6 carbon compound. Okay, then you have to draw the structure like this. This is called ring structure. Here we have carbon present in it. Okay, and otherwise this is the ring structure. I'll draw it. This is the ring structure. Okay, and also benzene ring can be drawn like this, but uh, in your syllabus you have to draw it like this: 1 2 3 4 5 6. Okay, then alternatively double bond present, there you have hydrogen. Okay, so this is the structure of benzene and molecular formula C6H6. Okay, so now come to the short answers question, short type. um, what are hydrocarbons and which hydrocarbon is, and give example. Sorry, the compound of, you can say the compounds of carbon and hydrogen are called hydrocarbons, and examples are like methane, ethane, etc., propane, etc. Okay, next question: how does carbon attain noble gas configuration? Carbon has 4 electron in outermost, 4 electron in outermost shell or in valence shell. Okay, outermost shell or valence shell, right? And it neither gain nor lose its electrons, right? It just share its electrons and form covalent bonds. Okay, next question we have, uh, why are covalent compounds generally poor conductor of electricity? See students, in case of covalent compounds, we in covalent compound, they don't have free electrons. Actually, covalent compound do not dissociate in the form of ions. Covalent compounds do not dissociate into ions, and they do not have free electrons. Okay, they do not have free electrons, so there will be no flow of charge. So there is no flow of charge, and that is why we can say they are poor conductor. Okay, next question we have, why homologous series of carbon, uh, why homologous series of carbon compound are called so, and write the chemical formula of 2 consecutive members of the homologous series and state the part of these compounds that determine their physical properties. Okay, if we say the homologous series, okay, then homologous series of carbon compound are called so because all member of homologous series have similar chemical properties but functional group, and same functional group, but their physical properties are different. Okay, so in case of homologous series, you can say homologous series of carbon compound are called because all members of homologous series have similar chemical properties and same functional groups, same functional groups and same general formula, right? So examples, like you can take the example of alcohol C2H5OH, another C3H7OH, next C4H9OH, like this. Okay, so physical properties. Physical properties, if I say physical properties of that homologous series are different. Why different? Because of the molecular formula is different. Okay, initial compounds, initial carbon compounds, like with the number of 1 to 7 8 are maybe gases in the gaseous state, or otherwise in the higher they are in liquid state, and more than that they are in solid state. Okay, and whereas chemical properties we have the same, because they constitute with the same functional group. So the chemical properties remains the same, but physical properties are different. Okay, next question. Write three characteristics of the compound of homologous series. Yes, very right. First, the general formula of all the compounds of the series are same. So first you can write that general formula of homologous series is same. Second, they have the same functional group. They have same functional group. And third property we have their physical properties are different, like melting point, boiling point, their density, all these things are different, right? Because of gradation of molecular formula, because of different molecular formula, but they have similar chemical properties, right? Next question we have the why carbon is unique in nature, right? Why carbon is unique in nature? First of all, write the three characteristics of, yes, in question 6 question we have why carbon is called unique in nature. Because of ability to make covalent bond with so many atoms, with heteroatoms, you can say. Ability to make covalent bonds. 4 valency means tetravalency. The property of catenation make the carbon unique element. Means in nutshell you can say that property of catenation and making bond with so many other elements make carbon unique element. And also you can write means two properties. First is catenation and second is tetravalent. And because of these two, because of the catenation and because of the tetravalency, you can say Carbon makes so many compounds. Carbon make the bond with so many compounds and show its unique property. Okay. So next question we have. So you can write in a way that ability to make covalent bonds, right, with with carbon itself and other atoms like hydrogen, oxygen, sulfur, nitrogen, right, which is called catenation, and also its tetra tetravalent in nature, because it's tetravalent in nature. These two things make the carbon unique in nature, right? C3H6, C3H6, 34H8, C5H10 belongs to the same homologous series. Yes, they belongs to the same homologous series. Why? See the difference in their carbon. C3H6. Next is C4H8. Then what is the difference between these two? CH2. Right? Next C5H10. Again the difference between these two is CH2. So they belongs to the same homologous series. And arrange the hydrocarbon in order of increasing boiling point. Okay. Increasing boiling, for first part, for increasing boiling point we have this C4H8, then C5H10. First compound we have C3H6, C4H8, C5H10, like this. Okay. Second, why melting point and boiling point of this are higher than C4H8? See, melting point and boiling point of C5H10 are higher than the C4H8 because of the molecular mass of C5H10 is higher than that of other two, right? So you can write because of higher molecular mass. So next question we have, name the compounds. Okay, name these, write the name of the given compound. So first is your pentene, butene and propene. Okay, next question we have, write the name of the given compound. Explain the two properties of the carbon which leads to the large number of compound we see around us. See the property of making the covalent bond with the other carbon atom and atom of the other element. It has 4 valency which help in making the chain with the other carbon atom. So the property of making covalent bond with the other carbon atom and the atom of the other elements, right? This is a unique property of carbon which is called as catenation, and it has 4 valency which is called as tetravalent. Okay, so catenation and tetravalency are the two most important properties of the carbon which make the large number of compound. Okay, and now comes to the long question answers. In long question answers, first question is define the covalent bond. Student, covalent bond means the sharing bond formed by the sharing of electrons. Okay, of sharing of electron between the atoms, and carbon formed covalent bond with the hydrogen, oxygen, as well as nitrogen, sulfur, etc. Next question, we have B part. We have what is fullerene and how it is different from the other allotropes of carbon. Fullerene is a allotrope of carbon, and another allotrope of carbon are graphite and diamond, where graphite is hexagonal and hexagonal in a hexagonal array placed in the layer one above the other. Each carbon atom is bonded with the three other atoms with the help of one double bond. And diamond is three-dimensional hard structure. Each carbon is bonded with all the other all other four carbon atom. In case of fullerene, carbon atom are arranged in the shape of football, right? And another question, next question we have, draw the electronic dot structure of H2S. See, this is sulfur. Sulfur we are having valence electron 1, 1, 2, 3, 4, 5 and 6, and H2. So one hydrogen this side, another hydrogen this side. This make the how this H2S is formed. Another structure we have F2. In case of F2, the valence electrons are 7. In outermost shell we have 7 electron. So F we have 2, 1, 2, 3, 4, 5, 6 and 7. Another F we have 1, 2, 3, 4, 5, 6 and 7. And this make this complete octet, and this way it completes octet. So this is the structure of F2. Next we have water. Water we have H2O. So O valence electron of oxygen, or valence electron oxygen has 6. 1, 2, 3, 4, 5 and 6, and here attached 2 hydrogen. So this and this is the structure of water. Next we have CH4. We did this so many times. Carbon we have 4 valence electron, and this 4 valence electron are attached to each hydrogen, and by this way the valency of carbon also completed. Okay, next question. Next we have CO2. Even CO2 we already did. We have 4 valence electron, 1, 2, 3, 4. Okay, you should not write in case of CO2 like this, because oxygen will have to make 2 bonds each side, 1, 2, 3, 4. You have to write like this in case of CO2, 1, 2, 3, 4. And here's the attachment of oxygen is there. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this is the way this carbon is attached to the hydrogen. I'll make it more neatly. We have this, see, 1, 2, 3, 4, and this oxygen 1, 2, 3, 4, 5, 6. In case of this oxygen 1, 2, 3, 4, 5, 6. See, in this case we will complete this. See, 1, 2, 3, 4, 5, 6, 7, 8. Okay, erase this. So you have to put like this: 1, 2, 3, 4, 5, 6, 7, 8. This complete oxygen, and this complete 1, 2, 3, 4, 5, 6 and 7, 8. This complete oxygen here. And what about carbon? Carbon is like this. So this is the structure of carbon dioxide. Thank you, students. Take care. Bye bye.